Hey, PerfBytes listeners, before you get started with today's episode, please pay attention to this message from our sponsor, SmartBear.
Whether you want to load test your APIs or your browser-based applications, you need to be able to easily scale up volume and identify problem areas. SmartBear has you covered. Load UI is the rock star of API load testing. Using an intuitive, versatile design, Load UI gives you the power to scale up and out, letting you dial up high volume and real-world load from any number of local and remote computers, all within a single test environment. With Load UI, it's easy to create and configure tests incorporating all of your OS, application, and database statistics agentlessly. It's fully interactive too, so you can easily modify your test and fix errors on the fly. Load Complete is an astonishingly easy-to-use load testing tool for HTML, AJAX, and rich internet applications. Create and run automated load tests in minutes using a browser to naturally record your interactions with your website or app. You can scale up the number of virtual users, pull in data from Excel and other sources, monitor server resources during test execution, and even distribute your tests geographically. Reports and charts make it a breeze to explore aspects of how your site or app performs under pressure and ultimately pinpoint performance issues proactively. Load UI and Load Complete by SmartBear. Ensure outstanding performance across your entire web stack.
It's time for PerfBytes.
What the f*** is PerfBytes? The fourth square meal of the day. Don't bogart the PerfBytes. Waffles. Microwave ready. Blah, blah, blah. Add nutritional value to your brain. It's time for PerfBytes with your hosts Mark Tomlinson, James Pulley, and Howard Chorney. PerfBytes.
Whatever.
Greetings, PerfByters. It's once again time for another episode of PerfBytes with your inexhaustibly triangular hosts, Mark Tomlinson and James Pulley. And joining us again is the founder and newest PerfBytes co-host, Howard Chorney. Howard, how are you?
Well, Mark, I'm fine today. How are you?
I'm pretty good. You mentioned earlier that we need to get your name in the intro.
Yeah.
So we'll put your name in the intro officially.
I feel
So Mark, I want to take issue with you on the triangular side. I'm feeling fairly rhomboidal.
Rhomboidal.
Yes.
And why are you rhomboidal? Is that the verb?
I just have more points than a triangle today.
Sure.
Yeah.
I don't think there's anything wrong with that.
Yeah.
Rhomboidal. It's a Sunday night and an evening, and like in good fare in the evening, we sometimes have with PerfBytes and Perf Performance Testers, we have a single malt Scotch. I'm having just a Lagavulin 12. Now I've had a Lagavulin 16, which was really, really nice in the past. So the 12 is not bad either. It's still got that Lagavulin flavor. It's very tasty. James?
Actually, I'm having a glass of Charles Shaw. $3 Chuck.
$3 Chuck.
But I'm using the Nathan Mervold method for aging the wine.
What is that?
So you take the wine, you put it in a Waring blender, and turn it on for 10 seconds.
It's like super aeration.
It's like super oxidation, and it adds 5 to 10 years to the wine. And I got to say, it does change the character of the wine.
Oh.
So do you plan on drinking that wine for 5 or 10 minutes? I mean, years?
Well, I will probably get a new bottle in that period of time.
I would think.
Yeah. It's $3 Chuck, but it does fare favorably to the official wine of PerfBytes Manifesto, unaerated. So the $3 bottle fares favorably against the $12 bottle.
Oh, yes.
So I'm just really curious. Do you take a funnel and pour the wine back in the bottle, or do you pour it in a carafe after you put it in the blender?
Unaerated, yes.
Oh, no. I just poured out enough for a very large glass.
I see.
And aerated just that amount, and then poured it from the blender into the glass.
So you're just you're blendering per drink per se.
Yeah, and I let the kind of sea foam coalesce and abate at the top before I drank it. Yeah.
Yeah, very nice.
Very cool. Well, welcome once again, guys. It's nice to be on the podcast with you, no matter what it is you may or may not be drinking.
Don't you want to know what I'm drinking, Mark?
Well, you're a teetotaler, Howard, so maybe you're having a spritzer, or
I'm having a lovely glass of filtered water.
That's good. I don't know about you. In Philly, there's all kinds of fluorides in the water here, which is good because you don't go to the dentist, but it's not very tasty.
Or extra funky.
Exactly. So today, our topic today is web service performance, and this was sent in from a listener to the Ask at PerfBytes inbox, which we have mentioned a few times, but it's really taking off. And this came from a fellow by the name of Sandeep, and he wrote to us, and I apologize, Howard. He didn't know you were fully with us.
I know I'm not. I won't be cranky anymore, I promise.
It says, hello, Mark and James, and Howard. I don't know if he knew, and Howard. Hello, PerfBytes guys. Thanks for putting so much effort in these great shows. I was browsing through the catalog to find something on web services performance testing. I did not see an episode dedicated to it. I'm sure you might have talked about it in some episodes, but are you planning a dedicated show on this specific topic anytime soon? I remember listening to one show where you talked about headless performance testing. I guess I'll try to find out which episode that was. Regards, Sandeep. So Sandeep, this is your lucky day because we're going to do a whole episode on web service performance. And James, you remember talking about headless? Something headless.
Yes, Sandeep, that really had nothing to do with architecture, but really had something to do with project managers. So it's easy to make that mistake. It happens.
Would that be like the four headless horsemen of project managers, or the project manager headless?
This is the project manager who shows up and says, well, I have 2 weeks on the schedule just before we ship. I have no budget. I have no requirements, and I'm too scared to cancel testing. So I'm going to give it to you knowing you're going to fail, and then I'm going to blame you.
That's headless. It's actually, you wouldn't necessarily need to be headless. You could still have the shape and appearance of a head, but no brain. I think it's brainless.
Yeah, absolutely.
Yeah,
exactly. So as we jump in to web services performance, I think the first thing we could help Sandeep with is just talk about how web service testing is different than normal web testing, because the architecture or the idea of testing at the web service layer, I mean, just saying that sentence means there's something different in the web services piece.
So Mark, really, web services is all about the web growing up in many cases. So you got a teenager, and you know what happens when you get a teenager and they use technology a lot. Well, they tend to put on a little weight. Well, this is what's happening with clients in the web universe. They're getting more and more sophisticated. They're getting thicker. If you remember the original web was really just thin. It was a scrape of a GUI. It was a keyboard monitor. It was kind of like DOS 1.0 for Microsoft. It didn't do a whole lot, but it was nice and it was friendly and it helped you get around. Now there's a lot more intelligence in the client, and going along with that, since the full-blown interface is out at the client here, we can skinny up the protocol for what's being sent back and forth. We no longer have to ask for all the different page components because they're in the client already. And instead, we can make one request back for specific pieces of data and bring it back. So much more like a traditional two-tier client server model.
Could be more traditional. I think one of the other reasons, aside from the growth of the client getting fatter again, like a good teenager who eats too much pizza, would just also be that I think there's a lot of integration of data sources that happened. So you had disparate, different data sources that all had to come together and provide data to a given application for some purpose. And so if the UI, if you think of something like what's like the Google portal, right? iGoogle, you have like all the different pieces of it. Yahoo has a portal, and there's many different components on the page that are getting loaded, and they're all loaded from separate, disparate data sources. So the idea that it's not all in one monolithic database anymore, or you've got a company that's like, well, we're going to take those guys and those guys and those guys and those guys. It's more like a smorgasbord. If you go to go to buffet, and you're going to take a little data from here and a little data from there, and then you take two pieces of data with Thousand Island dressing on them, and then another piece of, and then don't forget you have room for the chocolate covered data with the whipped cream on the top at the very end, and then you have like.
But Mark, there's some advantages here that come with this skinnier approach.
Yeah.
Where you can go to the buffet and you can select different pieces, and since we're using the HTTP transport, which everybody more or less trusts,
that's true.
You can now leverage these APIs expressed as web services to third parties. As you said, the Google, the Yahoo, the things of that nature. You as a third party, you can build an app which leverage their web services calls back to collect some data. And these web services calls not only can be from public providers, but they can be for private enterprises. Let's say you are a Sprint and you want to allow a Best Buy or a Walmart to sign up individuals for your services in their stores. You can leverage these express web services to allow them to do just that. So there's a lot of benefits here to the web growing up and the communication interface getting skinnier. And in some cases it's skinnier, but it's meaner. It's like a little athlete in this case. Skinnier, lean, a lot of sinew, but effective.
James, it's interesting you say that because one of our last testing projects I was involved in, we were actually using one of these third-party host web services company. And the way we tested it was using you ready for this? Product manager, headless testing.
Oh dear.
Oh.
That's terrible. So it really is. So Howard, to this point, if the web is evolving, and as James, you point out, the API layer, we can do this through a web services SOAP or REST interface. In the old days, you'd have an EDI interface, or you'd build like a tunneled RPC connection between to your partner or to a business partner or another division. These were very hard-coded, schema-dependent, and hardened API interactions between two systems. And I think if you hear these two different references in web services between SOAP and REST, SOAP has been around for quite a while, maybe more than 10 years. REST, maybe just in the last few years, are more popular. But Howard, you did some research between the differences between SOAP and REST. And how would you make sense of the difference between SOAP and REST?
Let's talk about, let's go on some high-level differences between the two. So one difference is that REST is tied exclusively to the HTTP transport model, where if you use a SOAP service, you can use SMTP or HTTP on your application layer protocols on your transport. Well, that would be one of them. Another one that is interesting to me, with REST, there's no constraints on your payloads. You can basically pop anything through it. But with SOAP, you really have to stick to the SOAP schema when you're using a SOAP service.
Yeah. Or if people look it up through like in the old days, you look it up through the WSDL, you discover the particular schema you're going to use, and it's sort of like automating a very hardened way of getting data back and forth through SOAP, where REST is a little more loosely defined and more flexible. And that's one way to think of it.
Think about this from an architecture perspective. If you're doing response time, it's critically important whether you know where it's SOAP or REST and what your transport is. Because if you look at SMTP, which is a simple mail transfer protocol, it has guaranteed delivery, but no guarantee of response time.
Well, it's interesting you bring this up. Before I say something, Howard, you were going to say something first.
Well, I just wanted to actually build on that. And I recall back in the days when I first started learning about, SOAP services, which were obviously out before REST, they were very much geared towards SMTP, and they really were used more in the mail transports than anything else.
Yeah, bringing up the idea of SMTP brings up one other aspect of web services that I'm sure Sandeep is going to want to know, which is sort of the difference between synchronous and asynchronous calls. And the idea, let's say you're going through SMTP, so you could think of it as a mail transport. It's fairly asynchronous. You send a message, and you may or may not get a message back. With the way web services through SMTP works, it is fairly instantaneous, the way you would actually get the message response back, like an acknowledgement. But if you look at applications that are using web services, they may or may not be synchronous or asynchronous, and that's a good question to ask your development person or your product owner or technical product owner. Hey, how many web services are being made how many calls are being made behind the client, and how many of those are synchronous, meaning they're required for the page load and there may be a user waiting on them, or they're asynchronous, which might mean, hey, they get fired off in the background and we're not really waiting for them, and they may or may not return in the time that the user clicks on something else. So thinking of web service testing in two different ways, between the application may be synchronous or asynchronous, is another important thing that we might bring up. Now, Howard, we talked a little bit about different tools for working with web services in service-oriented architectures in SOA, and ESBs, which is an enterprise service bus. What's the ESB part that what would Sandeep need to know? What's an ESB?
Well, an enterprise service bus, and there'll be a bunch of services hanging off this particular bus that will get called out when needed. That's really what an enterprise service bus does. Do you want to beef it up?
So Howard, if I was to paraphrase you, we have these publicly exposed SOAP or REST services as entrance points to the bus. We have something that's picking them up and servicing them off the bus. We have a call going in, we have a call going out. And a lot of times we have questions of what is the performance of the service bus? And that's a difficult question to answer independent of the services on top of it. So Mark, if I recall a conversation you and I had earlier, you had mentioned something about, hey, what about service virtualization and ESB stubbing?
Yeah, and you can think of one way of like a way of building systems and applications that use an ESB are very dependent on other services within the bus. In fact, they're very much so not standalone buses.
Well, that's what it's all about, right? It's all about, upstreaming and down. What services are going to be upstreamed and downstreamed and picked up off the bus, right?
Right. So Sandeep's going to need to know that as you wander into doing testing of web services, you might just be testing one particular web service app that does one thing, even though if it has dependencies out in the ESB, you could consider it like a service cloud. An ESB is sort of, like you say, hanging off that. There may be things you need to be aware of that are not just your application, but there could be other calls that are made into the ESB where where do I get the input data for my script in order to load test this given web service? Or if there's data that comes out, well, do I need to correlate a sequence of web service calls in order to meet a business process? So when I bring up this thing about ESBs, you might have development teams that have only built 20% of all the services that they're going to build, and you need to start testing today. Well, what if there's... You know what I mean?
Yeah, I do. And, a lot of these services may be third-party callouts that are really out of your control, but you still have to test them or figure out how it's going to react with whatever site that you're working on and testing. This is where I'd want to use a service virtualization tool, especially on those third-party callouts, because let's say in the case you're doing some sort of e-commerce site. Why do I always talk about e-commerce? Because it's basically over the past 5 or 6 years. That's what I've been working on. But anyways, if you're going to want to go to do an add to cart and then you're going to want to do a checkout and understand what the checkout is, a lot of times you're not going to be able to use that credit card call. So you're going to virtualize that service with something like ITKO or the HP tool or one of the other many tools out there that you can do service virtualization with.
Sure, or homegrown. But this is something that's is important, that web services, unlike old monolithic applications where you waited 5 iterations and then boom, you got your app. Sometimes web services, they're built sort of iteratively, piecemeal. You get the first 3 running, then you get 2 more, and then 4 more, and then 6 more. And then you have the whole suite of web services, and you sort of test them in this incremental kind of spiral methodology, which is why web services and Agile and that are so complementary in that point. Before we go on, and we'll get into the next step, which is sort of building a web service performance test, let's take a brief break for a word from our sponsor, Nuco. Hosting for PerfBytes has been provided by Nuco, new centers of excellence in performance engineering. The Script Farm, LoadRunner by the Hour, Cloud Architect, Videratech, and LightSquare. For more information, visit the website www.newcoe.com or call 888-212-1104. So I think that's a good takeaway as we start looking at how Sandeep might approach this. How is a web service different than other stuff? In the next section here, we should talk a little bit about, like, if you're going to get started putting together a web service performance test. I think the first place that the biggest difference for traditional load testers or web load testers is that in the tool, the tool is going to look differently. Now, if I'm in a load runner world, you may not use the vanilla HTTP web virtual user. Maybe there's a web services virtual user or a SOA virtual user, or these different types that have support for direct SOAP or REST calls. If I'm in JMeter, there's, you can get the JMeter plugins with a REST sampler versus just a raw WinSock or a raw HTTP request. But James, I mean, how do you see the test tool scripting being different when it comes to web services?
So here's one of the great advantages of web services testing, whether it's REST-based or SOAP-based, is because it leverages HTTP as a transport, you're able to utilize all the current tools on the market that have HTTP test capability. And that's from the free as in beer stuff at the bottom end, and JMeter, Grinder,
Gatling,
and all the way up to whatever tool you want on the commercial side, because they all support HTTP as a transport.
Right.
Now, you are going to wind up recording in proxy mode.
Yeah.
You're going to make yourself a man in the middle, and you could be recording in proxy mode between a Macintosh and your source destination.
So, James, would you have to go out and get one of these third-party proxy tools, or would most of the tools that you use today provide the proxy for you?
Generally, all the tools on the market have a recording proxy of one nature or another.
You think of like Load UI Web and the Test Complete stuff that's now from SmartPair can both just grab any proxy. JMeter has a recording proxy. Load Runner's had it forever. SOSTA, the Cloud Test stuff, has a really nice recording proxy. But again, what James, I think you're getting at is that old hook recording, which was hooking in a browser, or you're really hooking at a higher level within the interactions of the client. Here's the other advantage. Some people say, like a rich web app, you wouldn't want to do a proxy-based recording because you need TrueClient, or you need Selenium or WebDriver, or some of these full-on rich interactions of the browser. Web services are fairly atomic, data-related send and receive calls. So recording in the proxy for web services, well, the sequence of calls is a lot, dare I say, it's like WinSock almost, James. Just send and receive, send and receive, send and receive.
It's a lot simpler. It does look like a traditional two-tier client server. I send a request, I get a response. I send a request, I get a response. And correlation between those requests, that is taking data from a previous request to put it in a future request, actually becomes a lot simpler.
Yeah.
Because what you're generally receiving back is some sort of XML data stream that you can parse and pull information out of. Yep. Now, there is one gotcha generally that seems to impact SOAP more than anything else, is that as you move from tool A to tool B, you start saying, hey, well, tool B is not operating the same way as tool A. That's because all the tools make different assumptions about what headers need to be in place.
That's true.
By default. Some will record the headers, some will put some default headers in that need to be modified, some will make headers blank. But in general, if you have a problem moving from A to B to C to D to plural Z alpha, you need to look at the headers that either are or are not being recorded that are appropriate to your web services call.
I find in a lot of situations, I've got a functional testing team that's doing, let's say, SOAP UI, or they're doing even manual scripted Python or wget kind of calls to web services to test them. And, it's just a manual copy and paste where I go get their script and I read through it and I find the endpoint, I find the headers, and then I copy and paste the payload into my tool, be it Load Runner or Cloud Test Lite, SmartBear, you name it. Load UI, you can actually pull some of this over and configure it as well. And, you might find that manually writing a specific web service script could be easier than recording, but this is the gotcha, right? The real value of recording and proxy-based recording is you see all the fields that are being sent and received by the client. And this is important from a REST perspective, Howard. I think as you were looking at SOAP versus REST, it gets back to that thing you were saying before. If SOAP has a specific schema and a specific set of payload, whereas REST is more flexible, if you write the script by hand, you might miss out on some of the fields within the payload, right?
Yeah, absolutely. So I really like that idea of actually recording it first and then going in and maneuvering it and editing it and modifying it as you go along. I think it's probably the best of both worlds. But then again, who would just ever go and record and play back and call it their test anyway?
Well, that's the $10 an hour load testing person.
Is that it? What it is?
Well,
I got
but
you.
the point is, like, let's say even if you do a great job of building a script, especially in the REST world, let's say in version 2, the devs come along and they add 2 more fields. Your script may still run successfully. It may not show an error. It may give you a 200 response and everything's great. But those 2 fields, if they're required fields, you might get an exception in the payload or in the response code that you get back, a JSON response or XML. And this is where script, raw HTTP may be 200, but the payload itself may show some error state. And you need to be able to do checkpoints and correlations to grab those out of there and double check what's the response code from the actual web service itself. So the validation and checkpoints that you put in scripting are very, very different to that respect.
Yeah, I mean, Mark, I can't imagine that a developer would add a capability and then not inform QA, especially in an agile environment where they're supposed to be working side by side.
Well,
by the way, I have a deer in the headlights look right now.
Well, if they were side by side, why would anyone need to know? Because they'd be holding hands and singing "Kumbaya" as everything was being developed.
Right, but that's just it. Some people make assumptions about what information is valuable to their counterpart when you're paired up. So you might make an assumption that, well, I just did this and nobody cares about that. And a tester goes, wait a minute, my script doesn't matter.
And that's where the proxy model provides an objective basis. There is no arguing at that point.
Yeah, here's a raw recording that these are the exact fields that are being sent in and out. So testing tool-wise, I think to summarize a little bit, your existing tools, whatever you're familiar with, they're using, probably already support this at the HTTP record and replay. Use the proxy recording to make sure you're capturing the real, most current payloads field by field and make sure you've got that done correctly. And then look at, be aware that the script may change or the web service may change and you're keeping the script in control. Use a checkpoint or some kind of assertion on the text inside the payload that you get back to make sure it's not just the HTTP 200 or 500 or 400, but you're actually looking at a response code within the payload itself, much like you would with a web UI. Let's talk a little bit about monitoring as well, because most people should be monitoring when they're testing. What would you monitor? Is there anything different in the web services world, James, when it comes to monitoring?
Well, I think in the web services world, we have a distinct rational reason to use a World Wide Web Consortium field, the W3C time taken field.
And most tools know nothing about this.
No. They know nothing about this. This is tracked by every single web server. So because you have to go through the web tier for a web services call, SOAP or REST, the result of that request is going to wind up in the HTTP access log. Even if you're using something like a Tomcat as an app server or a JBoss, they still have that web tier. They still have the HTTP access log. And track the time taken field. That will give you the time required to process that response at the web tier level for every single request.
So, James, are you suggesting we sit there and run through logs?
What I'm suggesting is at the end of the test, pull the logs and then process this extra amount of information that you're provided.
Or you can put together a log monitor, like you could grab Splunk or a Logstash, off of that log and put the filter in place to say, show me a graphing. You could pull that into Graphite and show a graph of time taken.
And the advantage of this is you can look at this in production as well. It gives you a nice monitoring basis that you can translate from functional to performance to production.
Wow.
So that life cycle of the transaction on a common monitored basis throughout.
Sounds very DevOps to me.
Oh, it is. It's DevOps.
Oh, God. Oh, you labeled me.
Yep. You said a DevOps thing, dude.
I'm feeling ill.
Yeah. But I'll be really honest, James. I mean, to some extent, if you're just getting started with web service load testing, just the response time, start transaction, end transaction, start timer, end timer, should give you a fairly good idea at the atomic method level of a web service as to which the response time for that method. It shouldn't be dramatically different if you're testing within the lab directly.
That's true. The only difference between what you would get with the W3C time taken and what's at your test tool is I don't think you get the last ACK going back to the server.
That's right.
At the HTTP access layer. So it'll be pretty close. It'll be within, a millisecond or two.
Yep.
The advantage is that if one web service kicks off multiple others, is that you could track internally what's happening as multiple other services cascade downstream.
Right. And this is if you're in a really, really messy ESB where people are incestuously calling back and forth and nesting calls. It's kind of nuts. Howard, you're going to say?
Yeah, you brought up a really good point, though, on the testing in the lab with all the web services all nice and close and tucked in near your load generators and such. It's probably not going to be the case in the real world, is it?
It couldn't be, Howard. If you're testing, let's say, a public web service and you really don't control it, you're just consuming it as part of the test. One, you may stub that out or just comment out the call. But if you're actually running load against it and it's across the wire, or let's say you're doing a testing in production off hours, you're going to start seeing that there's a difference between your test tool measurement of response time and the W3C time taken value in the logs. Could be very different as you had more network latency.
So, which kind of brings up a point of how do we really start to optimize these things, or did I just jump the gun?
You totally jumped the gun.
But it does bring up that we need more information from a monitoring perspective in order to be able to optimize these things.
Yeah. Now, there's a few other things that we can monitor for web services testing. And the first thing I'll say is that, if you're in the SOAP world, and I think, Howard, you pointed this out, that SOAP probably has a lot more overhead in terms of parsing and transforming any of the calls to make sure that they're obeying a given schema and they're working correctly, whereas REST may be more lightweight. Is that your understanding?
Yes, it absolutely is. So actually, looking at the official guide to differences between SOAP and REST, and here are the real technical terms, REST is less verbose and SOAP is more verbose.
Right. And if more verbose means I've got to parse more things.
Oh, absolutely.
And if that's coming out of an encoded object, I've got to transform that. If it's XML, where SOAP and XML might be very different than REST, which could be clear text or could still be encoded, but it might be a JSON payload that's not being parsed like XML would be, whereas XML could be very, very parsing or paying a transformation overhead. The biggest thing I find that Sandeep might want to know is that when you're testing an individual web service or a method, whether it's REST or SOAP, regardless, that method, more often than not, it's submitting data and receiving data from a data source, and therefore there's a relationship between the web service and the data behind that web service. And it could be a single data source or multiple data sources. And so it's really important to map and understand what data am I sending in, where is it going to, if it's a select statement, if it's an update statement, if you're inserting new data, and where am I retrieving data back from, right? So think about a web service being very closely tied to the back end of the application stack. And so therefore, you might need to look at things like the number of connections between the app server and the database server in order to make sure that that's healthy. Look at query performance inside the database. There may be some special things through this interface on the app server called JMX. So you might do JMX app server metrics, or use a tool like Dynatrace. There's also some other diagnostics tools, App Dynamics. I think, Howard, you mentioned App Dynamics.
Yes, App Dynamics. Yeah. I've worked with both. I've actually worked with both.
Yeah, and you've got CA has Wiley, some of the classic diagnostics tools that can profile these things for you.
Hey, let's not forget New Relic, who went IPO last December.
Woo-hoo.
It was in our end of the year program.
Yeah, New Relic, exactly. But think about monitoring the web service, app server, or app servers themselves connecting to the data sources directly and monitoring both of those. And you might find that if something is really slow, but the database is looking really, really fast, that it's actually overhead within the parsing and the code that's within the app server. Vice versa, you might find something that's really slow, But on the app server, you can't really tell whether it's slow, but the database correlating that particular call, oh, this store procedure gets called, so it's really, really slow.
Hey, Mark, one thought comes to mind. What about thread count? Would that make a difference?
It could make it just like it, but that's more similar to, I think, web server tuning. I mean, it's more like app server tuning in the web 3-tier web world where you have enough max threads, min threads. You don't want to spin up on the fly the number of threads depending on the weight of the session. But I think also you could limit your throughput artificially, like anything, by the max number of threads, and of course monitoring the number of active threads and the number of connections in the connection pool. Especially in web services being data intensive, you would want to make sure you have a multi-lane highway. The other thing I wanted to bring up for Sandeep is to think about test data. And in the web services world, because the payloads that you're sending and receiving with a web service test script are very data intensive. They're not UI, GUI kinds of things.
Now, Mark, I've got to tell you, there are common questions on this. Really common questions. Like, I've got this web services call and I've got this encryption stuff going on and I don't know how to address it. And this is being asked in public forums. You have no way to tell what the encryption method is or what the key length is or anything else. But usually it's not encryption. You know what it is?
What?
It's base64 encoding.
Base64 encoding. Would you guys do me a favor? Look up really quickly. I know if you're in VUGen, you got the edict and decoder, and you can have a base64 decoder right in VUGen. I think there's one in Cloud Test Lite as well, where you can grab anything that you record and throw it in there and decode it, and you'll find it ends up just being decoded into clear text. And you can read it, you can correlate it, you can pull data out, you can do assertions on it, you can parameterize it as well. But there's a few other tools. I think the Charles proxy that I use for sort of sniffing web service calls or HTTP calls will do base64 decoding. It'll actually do AES decryption as well if you know the passphrase, and you can start getting the password to do the decryption.
I believe Fiddler will do the same thing. Well, no.
Yeah, Fiddler will do the same thing. So,
and I do believe that LoadRunner uses Fiddler.
The latest release for the proxy recorder default has gone to Fiddler base. Yeah.
So, but overall, the tip around test data for Sandeep is that your data-driven tests from a CSV, from a data moving in, user login, password authentication from a GUI standpoint, that's going to change. Because there could be multiple fields being submitted to a data source or retrieved from a data source that actually, it's more raw is a way to think about it. You're really in the back-end layers of the architecture where you're sending and receiving data. Therefore, you'll have more data and it looks more raw because you're not really doing UI level type scripting where you log in, click a button, click a button, click a button. And behind the scenes, that all gets turned into an action. Insert new customer, XYZ, address, PDQ kind of thing.
Can we go back to the proxy for a minute? Because I just want to make a point on the proxy, as I've used a couple of them. From a tool perspective, if you can get a tool like LoadRunner or Cloud Test or whatever, where they actually build a proxy in, it's not that difficult to use because it's pretty intuitive and almost automatic. But if you're going to configure some of these proxies yourself, Sandeep, you need to really be careful because there's some complexity to configuring each proxy, and it's actually different with any proxy engine you're going to use. So just kind of something to think about.
Yeah, like, do you have an example of like something he would configure? It's like you may even have someone to give a particular route, and whether you have certificates that get in the proxy, you might have to pass a certificate.
Well, I see all the time people want to use Fiddler because it's free and open source, not realizing that the tools have built-in proxy recording capability.
And I think you made an important point too. If you're using HTTPS SSL traffic, sometimes you need to know the key.
You have to know the key and have access with either a primary certificate or even a secondary certificate. Let's say you're going through a load balancer, you got a secondary certificate. You'll need the testing tool or the proxy to be able to obey that. And that could really stop your recording and replay in its tracks. for SSL, which is pretty common with secure web services, right?
I'm going to say from experience too, where I've configured a couple of these different proxies where I had to configure them myself. I mean, it took me a day, and I'm not going to be embarrassed to say that because it was a lot of reading, a lot of researching. There are a lot of different versions out there of these proxy engines, so you really, really have to make sure that you map it out before you install it.
And if you're really lucky, here's another thing. If you figure out the scheme, the key or the SSL, once you get the tool or the proxy configured right, hopefully all of the people developing web services at your company fall into that same pattern. And the tough part is if you find a lot of disparity, you go to one group, one app, and they're different than another group and another app and another group, and they're all totally different, then Howard, Sandeep's going to be spending days and days and days just figuring out each one uniquely. Hopefully you have some standards across your company in terms of SSL certificates and such that it's configured correctly, and you're not paying that price over and over again to figure that out.
Now, Mark, there is something that is very delightful that we need to
Yes.
talk about. Web services, because they are typically exposed to third parties as well as internally, are more likely to have actual expressed requirements.
No, you're kidding me.
Response time.
Data exchange. If you think of a business to business partnerships, I'm sending you data, you're sending me data kind of thing. Usually there's a legal contract versus, hey, let's build a website and go sell something. Woohoo!
Let's go sell unicorns and rainbows.
Unicorns and rainbows. And I'm going to tweet out, hey, the latest Unicorn 2.0 is available now from the website. Yeah, that's kind of crazy. So there are response time requirements that may or may not be defined for your web service. I think I agree with James.
I wonder if Prancer size is different for unicorns.
It is different. It's a totally different way of. I'll just shut up. I'm not going to start it. Exactly. So the last thing for Sandeep to really pick up on, as James, you point out, is a response time requirement. And you're not rendering a whole page worth of data like an article to read or a product catalog or images and all of this stuff through a web service. Most likely, the web service is just spitting back data of some sort. And therefore, on average, your response time, and I see this almost everywhere, response times typically are going to be sub-second, especially if you're doing web services between systems inside the same data center. And that's physically like on-premise in the same location. Now, if you move your web service and they're still sort of within the same system, but they're in the cloud, you might see that there's a little more tolerance for some latency. Let's say you've got 3 different AWS data centers and they're kind of going back and forth. If you're just a public web service, you're probably going to be several seconds in a response time on a web service call. And you think of 100 web service calls loading behind the Amazon web page, and maybe 40 of them are sub-second. The other ones are more asynchronous. And, if you scroll down, it finally loads. There's some other stuff. And we're just talking about different pieces of data that get loaded into the UI. So no matter what it is you need to put together for your test, no matter whether it's on-premise, data center, sub-second, whatever, all of those response times are the same as the web. There is a business need. There's a requirement. As James points out, there could be a legal contract that says thou shalt respond within less than 500 milliseconds on this web service. And you need to keep digging until somebody says, hey, I know what this web service is used for in the real world, and it needs to be sub-second or less than 2 seconds or something like that. So keep digging just like you would with any other normal load testing. So James, right now we're and Howard. Hey, Howard. Just got to break myself of the habits, brother. So Howard, we're going to take a little break now for a public service announcement about the procurement department.
Mark, have you ever been let down by the quality of a performance testing contractor or service provider who claimed to know more about system performance than they did in reality?
Yes, James.
Perhaps it's time to start working proactively with our friends in the Services Procurement Department and help them to learn about performance testing and engineering resources.
I know what you mean, Mark. Certifications are not a surefire method of screening candidates.
And generally there's no school or academic accreditation for performance skill.
Experience must be backed up by references and recommendations from former employers.
Procurement people should remember that being a general tester is not a qualification for doing performance work. So please don't just reassign those guys from QA.
Always remember John Ruskin's common law of business balance, which prohibits paying a little and getting a lot. PerfBytes encourages you to develop a positive relationship with your brothers and sisters in the Services Procurement Department because we know that they know less than you know about the resources you need to be successful in performance.
Okay, so let's think a little bit about the last part. Let's say Sandeep takes all of our advice, and for some reason he understood most of it, and he's up and running. He's running some load tests. He's monitoring, and he's got everything underway. Howard, he's still just doing performance testing. He's not really maybe doing performance engineering or optimization for web services proactively. So how should Sandeep sort of approach working more proactively, sort of getting ahead of development?
So Mark, I got to tell you, Mark, this class of developers that builds web services, they are highly suggestive to beer bribery. It seems to be a universal constant for this class of developer. If you say, "Hey, I'd like to discuss performance and I have free beer," it's almost a certainty that they will come and listen to you.
Well,
and actually have a conversation with you.
Well, James,
yeah,
I think that, again, if Sandeep, you want to go God, if I'm going to have to learn how to enunciate better.
Have you
No,
been
I
drinking?
haven't been drinking. Yeah, I've been drinking filtered water from the refrigerator.
You don't know what's in there.
I don't, but Sandeep, if you actually go and speak with your developers and show that you have an interest in what they're doing versus just bringing them problems, you may find that you can have some influence over what's going on.
And what you might find is this, like James, you say, it's not just that they're sort of maybe hipster, bearded, piercing sort of web service developers. You might find that there's a connection to the sort of an architectural thing, because web services, oftentimes the deployment project is connected to sort of, we're going to take over the world with a ESB architecture, a SOA architecture, or changes in architecture. And there may be a different level or type of dev that's different than sort of the everyday, let's build an app, build a GUI kind of testing and load testing. This might be an architectural group that you need to know as well, that build web services and do that.
And if you find an architect or developer named Pinky who's talking about taking over the world, that's the one you want to make your friend.
Pinky? What are you talking about?
Because he's the guy that's the front end of Brain.
Oh,
exactly.
Oh, that's right.
Pinky in the Brain. You want to hear something funny?
What?
My son got 2 rats this week in his own apartment. And he named the rats Pinky and the Brain.
I'm sorry, guys. I'm a Happy Days guy. So is Pinky Tuscadero.
Pinky Tuscadero. And her sister, Leather.
Leather she was awesome.
I'm much more into Leather.
So anyway, Sandeep, aside from Happy Days reruns and rats, you'll need this to learn how to optimize these things so you can start working with these dev teams and more like architecture teams. At the same time, don't forget the value you bring as a load tester to these architecture web services teams is that you remember that maybe this data is used by a real GUI and a real human being. And so you might be able to say, hey guys, the chain of these 6 web services calls end to end is a business process. And I understand from the product owner and the business analyst, this business process needs to complete in a number of minutes. There may be some Uber or Meta, response time requirements for end-to-end on the business process. That's always really good to remember. You might find these architectural web services guys are kind of deep in the weeds, and you can help them to understand the real world. If you come to them and say, hey, we'll get specific to a business case and the client side context for the data that's being load tested and brought back end to end. So you may have a secret weapon in your own understanding of multiple web services calls being chained together to perform some function for the business versus a purely architectural standpoint.
Let's talk about web services calls chained together.
Yeah.
Doesn't that kind of start to defeat the purpose of really efficient web services by chaining a bunch together?
Well, I guess it does. And that's sort of how maybe traditional app developers or client-server developers get thrown into web services, and they treat it like a protocol, and they're still building the same thick, bunged together, mixed context, interdependent, overly interdependent apps without saying, you know what, these are 25 discrete different services. I can call them in different arrangements. I can call them out of sequence. And this is, I think, Howard, this gets to a little of SOAP versus REST again, because SOAP was more like constructing a very specific type. It's more like the hierarchical library model for building an application or a program versus more open and loosely coupled REST services that are more flexible.
Yeah.
But in that collection, let's say you have a chain of web services, it's good for a load tester to know, hey, I kind of know the sequence that these web services are going to be called in the following kind of sequence, not just totally randomly, because we pull data from one web service, submit it to the next one, submit it to the next one, maybe not in perfect order, maybe somewhat in parallel. Your scripting gets more complex. But the truth is, the entire business process may still suffer because one or a couple of those calls, maybe it's got a database contention. Maybe it's got some other mutex built in there where you've got things submitted, but they don't come back fast enough. There's a JMS queue that just sits in a retry, or usually it's a data source of some sort. Or they've still coded a distributed transaction because they're not fully openly REST independent. So they've still got some sort of distributed transaction coded on the back end for the data source, trying to be ACID compliance when really eventually eventual consistency would be fine.
Well, Mark, what I see in a case like that, if I go and I record several times and I'm watching the performance and I see continuously that I have this sequence of requests of A through Q that are always occurring whenever I hit the OK button in the app, I'll actually call the developer up and say, hey, is there any way that we could collapse all these calls to one request? Because you're always making the same calls. How about a store procedure with another SOAP or REST call on top of it to collapse all of this? And that way we can take advantage of efficiencies on the back end for the data.
Well, talk about optimization, right? I mean, that would be the perfect thing to do versus having to call all 50 of them at the same time, whether you need them or not.
Yeah.
Yeah, I'll give you guys another thing I'm observing, which is maybe you have 6 different applications, and one of them is a very like you described, James, a very homogeneous step-by-step process using those web service calls. And you could do something like what I would call fast laning. So you actually don't use a web service for that app, and you get something that calls a single store procedure or a single transactional call. And you get all of the advantages of being transactionally within a single stack, and you don't have scale out. You'll inherit all the scale up problems, but you'll have this efficiency that's amazing that we got from old client server kind of world. Whereas all the other apps that are either changing more often or they're more random, they could live with discrete independent web service calls that have each service has its own context.
Absolutely.
And so you could do sort of this fast laning, saying for this app it's going direct and it's not collecting all of these web services. But I would even beg that that's still a rare case in because network speeds, because of capacity and resources being what they are today. Most often you can chain a lot of these things together unless they're giant queries, and then you just got to go at your data source and figure out whether I really need to be transactionally committed in those giant queries. Guys, let's talk about some other optimizations. Howard, you brought up one earlier about compression.
The oldest one in the book.
Yeah.
Compression, right? Works every time.
It works every time. You pay some CPU overhead, but again, if you've got, let's say, moderate to large payloads, and when I say large payloads, I'm talking something over half a meg, right? If it's less than half a meg, your compression is not going to be that huge, right? Maybe 10 to 15%. If you're half a meg in that payload, you're probably good just to turn it on all the time. And the thing with these web service calls, especially with data payloads, is they should be rather heterogeneous, right? So compression may help you on either end of the wire. And especially if you're running within the same data center, you're really just paying CPU overhead, and you'll probably have enough network to move things back and down the wire. You'll save a lot of network if you're moving payloads in a compressed fashion. James, what else? You mentioned something about scope as well. What do you mean by that?
It's real easy to convert direct queries or direct store procedures to web services, either SOAP or REST. And the problem with that is sending too much data back to the client.
Trying to do too much within one service.
Yeah, in many cases, we have these calls that are already in the middleware server, and they're simply just being converted and exposed. And they're, for whatever reason, they've not been optimized in the middleware server. So you have the scope where it brings back 100,000 rows of data, and then it sends three rows of data to the client. Well, if you're going to do this and you're going to expose these services downstream, let's make sure that the queries are highly optimized for the amount of data that is transferred from the data store to the middleware tier and then on to the client.
Yeah, that makes perfect sense. And that's making sure that you don't have a developer that's just trying to heap all sorts of different use cases within a single web service, right? It should be fairly discrete, and it could be sort of CRUD, create, read, update, delete kind of database stuff. It begs another question, James, about scale up and scale out, which are typical within the web architectures. Does scale up and scale out apply here with web services in any way, shape, or form?
Well, you have a horizontal scalability issue. That is, you can add more web tiers for more inbound processing. But on the scale up side of the house, you're generally not going to scale up on one box. You're not just going to keep putting web service A, B, C, D, and just keep going up and up and loading it up because, you're going to run out of capacity at some point.
Yeah, I could see that happening if you had a physical constraint, meaning you can only run one box in a branch office or a field office location. We had some geographical limitation that said you can only run all of your services on this one box for security reasons or for physical reasons. But scale out wise, the thing about these individual data calls is usually they're not like a UI. They don't have the same kind of session maintenance. It's just like an atomic kind of request. Here, give me the most recent activities for this given account.
Yeah. So you can do round robin very easily on a load balancer that comes in. Client A comes in, first request goes to server A, second request goes to server B, so on and so forth.
Yeah, and which enables you also to run these things in a more elastic cloud environment where you can add more nodes and keep scaling out that way horizontally. Howard, we talked a little bit about near and dear to our heart, sort of network latency and locations. I mean, if people are moving web services, if they want to optimize things where they're making a long trip from the app front end to a web service call on the back end, you might choose, if it's a public web service, you might choose a different web service that's closer to you. Let's say you're getting time and temperature or account information. I mean, what about choosing different public services or moving your own service to a data center that's closer to the client?
Well, you could definitely do that. I mean, there are a lot of our cloud providers today are all over the country, so that'd be one way to defeat that. I think something else, I mean, if we go back to something earlier we talked about, is compression would help that too. If you can compress the data, I think your location isn't as important. And I think it's really dependent on the service. I'm not so sure you can really regionalize a lot of different services.
Yeah, that's true.
One thing I like about some appliances, such as Riverbed, is they have the ability to break up the send and receive response and just send the pieces that are changing. So, for instance, on SOAP, all of those headers that go along with the SOAP request that's not there really with the REST request, that piece can be cached going both directions. So you can pick up some speed there. It's not a whole lot, but every little bit counts, I guess.
And the other beauty of that too is that all your TCP handshakes are done locally, and it will actually send the data from across from one accelerator to another via UDP. So you don't have to worry about the handshake going over a long distance where the handshakes happen locally.
Yeah, so that can cut down maybe 25 or 30% actually if it's very, very heavy or very chatty. Absolutely. And it also me think about authentication, because a big part of the security with layers within web services is that, you may have a credential in a messy ESB where you make a call into one web service. It needs to in turn make lots of calls behind into other web services. What you may find is you're having to re-authenticate multiple times or chain those things together in an inefficient way. And authentication itself, whether it's through LDAP or talking to Active Directory or however you're actually going to do that, that same handshaking, just infrastructure as well as the keys themselves, that can be overhead. So one of the advantages you might optimize is caching the actual authentication on the primary server you hit, and then be able to reuse those cached credentials with a session timeout for these other subsequent child calls to other services. The other thing you'll hear on PerfBytes a lot is we talk about the CDN, Content Distribution Network, being the panacea, right? Everyone that's on News of the Dam, they didn't use the CDN. In web services, one thing to keep in mind, even though it's a web infrastructure, a CDN is probably not going to help you. So Howard, why is a CDN not going to help most web service apps?
All right, so CDN is basically a big caching box, right? And CDNs use to cache static content. And most of the content that's going to be delivered by a web service is going to be dynamic. So CDN's not going to work. It's going to have to go back to origin or wherever whatever the web services is serving out the information from.
And if you did actually have more static data, let's say it's a set of resource lists like city, state, zip, things that don't change very often, you might not do that through a web service. You could have a web service call that just gets its source data from a static XML in cache, and you could just cache it not in origin. You could put it out there, but it's a resource file. It's not necessarily a web service call. You might not pay the cost of going through a web service. You would just load it in XML directly from the CDN. You wouldn't go through a web service at origin in order to turn around and go back out to the CDN and get that. That doesn't make any sense.
I mean, what are we really going to be using web services for anyways, right? Maybe for going out and doing credit card verification, going out and doing initial populations of search lists and things like that. Account information.
It's data interaction of some sort. But speaking of data interaction, James, near and dear to our hearts, I've been on the SQL Server team, you've been on the SQL Server team. Come on, database tuning, web services and optimization. I swear 90% of the time when it comes to some web service running slow, it's hanging on a database session and a bad query.
And you know what, Mark? All the database servers on the market seem to have a direct web services interface. You can actually send a query across web services, have it satisfied, and have it sent back in a structured SOAP response.
Yeah.
So you're right. There is in many cases a direct one-to-one relationship between these web services calls and a store procedure or a set of queries. And so the SQL profiler, the DB2 profiler, the AWR reports on Oracle, your MySQL profiler, all of those are critical to finding out, hey, what are the inefficiencies in these back-end queries that are simply just going to be projected through the web services tier.
Yeah, exactly. So if you may know the web service architect devs that are building the web services that you're testing. If you don't know the DBA or the database dev on their team, and they should have a database person on their team, you might want to be the person that collaborates, brings all those people together so you can trace down these queries. And like you say, pick out the profilers or tracing tools, again, like AppDynamics. Dynatrace is a really great tool for tracing these things and pull those things together for sure. So we've covered kind of the whole gamut here, sort of how is web services different than normal web testing. We've talked about testing tools and testing data, recording. We've covered just about everything into optimization, what kinds of optimizations fit well with web services. Guys, if I were Sandeep and I'm not.
No. Sandeep is taller than you.
Is he? He's probably taller. I think he has dark hair too. I've got the gray silver thing going.
I thought you were going to say you played Sandeep on TV or something like that. I'm not Sandeep, but I played him on TV.
For all we know, Sandeep has a very active career as an actor, wherever he is. Fine. So Sandeep, thank you very much for sending in your question to ask@perfbytes.com. Little did you know, we would give you an entire episode to go into everything that at least we could put together on how to approach web services performance testing. James, any last thoughts or advice for Sandeep?
Go out, have a good time, wear a leather apron.
What do you mean by that? That sounds kinky.
For protection.
Oh, sorry. Yeah. Make sure.
Yeah, it's like going into the shop and you go to the grinder,
Yes.
where you're shaping a piece of metal. And you got all that metal flakes flying off, and you want some protection. So you wear the big leather apron. Web services are like that.
Any last thoughts of advice for Sandeep as he ventures into web services testing?
Yes, Sandeep. Make sure you choose a good tool to do your web services testing with. Make sure you understand that this is not your normal web-based testing. You'll have to do a little more in-depth work. Be prepared to learn about how your proxies are going to work, and make sure you bring plenty of beer when you go talk to your developer.
My last piece of advice is to be the person that helps bring a larger context to these disparate and discrete web service calls and figure out what is this really delivering to the end user or to the business. And as a performance tester, you can load test something, but load test something knowing what the value is for the response time or the throughput or the scalability of that collection of web services, not just a technical test. Make that extra effort to connect the business goals back to the chaining or sequence of web service calls you're testing. This is really good, guys. Thanks very much. This is awesome. Well, PerfBytes listeners, once again, we come to the end of another banana-filled episode of PerfBytes. And as always, we'd like to thank all you PerfBytes minions for taking the time to listen to the show today.
Mom, welcome back from your Panamanian cruise, and thank you for tuning in.
Is that like the Panamanian devil?
No. They did buy hats while they were there, though.
They bought hats. Yeah,
Did they buy
great.
Panama hats?
They bought Panama hats.
Oh, that's awesome.
Panamanian
Panama
hats. Yeah.
hats.
Howard, go ahead.
I would like to say thank you to my good friends Mark and James for allowing me to be a member of the cast, to enjoy all the pageantry that is PerfBytes. And as always, which will become a tradition, I'd like to thank my lovely wife for putting up with me.
Very good. I will, as always, thanks to the sexy Irish voice of PerfBytes, and special thanks to our sponsor, Smart Bear, for their sponsorship and support of the PerfBytes show and the PerfBytes community.
Mark, Howard, today's show is powered by Minions. If you would like to become a minion, please send us a note at ask@perfbytes.com.
Yes. And please remember that the content of this PerfBytes episode is copyrighted and protected by the fart gun from the movie Despicable Me. Trust me, you do not want to get shot with the Minion fart gun ever.
And for more information about PerfBytes, visit the show's website, http://www.perfbytes.com, or follow us on Twitter, Facebook, and of course, you can always subscribe and listen to the PerfBytes podcast. Say that 3 times fast on iHeartRadio, iTunes, TuneIn Radio, Stitcher, and testingpodcast.com. And don't forget, if you're not listening to the show, you need to tell your friends so they can listen to the show. That didn't make sense. Just open your favorite listening app and search for PerfBytes. Click the subscribe button or favorites button or whatever button you have.
Whatever button you have.
You're pushing my buttons right now, let me tell you.
Guys, the PerfBytes show and staff are supporters of the Practical Performance Analyst, the Performance Engineering Book of Knowledge, the Computer Measurement Group, the Workshop on Performance and Reliability, and of course, the Software Test Professionals community of software testers. We hope to see you at the next STPCon conference in April 2015 in San Diego. Check more out at stpcon.com.
Very good. Thanks, everyone, for listening today. And remember to email your questions and comments to ask@perfbytes.com, just like Sandeep. Who knows if your ideas or questions may turn into an entire episode to dig into all of the things you have to ask. Thanks very much for listening, everyone, and we'll see you next week. Howard and James, thanks for joining me, and we'll talk to you in the next episode of PerfBytes.
Bye, Mark. Bye, James.
Bye, guys.
Have a great week.